So hello everybody. Thank you again for the opportunity for us to present this Python package. So Cyril and I developed this package last year, and it's about basically plotting and comparing histogram in a scalable way, and also with a publication-ready style. So as I said, the presentation is in two parts. The first part is this presentation, when I will go through the basic concept and the basic of what the histogram can provide. And then we have Cyril will do a live demonstration of the package. So yeah, to see how the functions behave in real life examples. Okay, so the goal of the package is to provide a tool to make standard high energy physics plots in a scalable way and a publication ready style. So the physicists can focus more on doing physics than tuning or fine tuning the plots for publication. And the methods to do that is basically we provide functions that are wrappers around the matplotlib to plot what is called the boost-histogram object. So boost-histogram is a very powerful tool from the scikit help package. And the main feature of this package is that first, the style is publication ready with little to no efforts. The scalability with respect to data size, because we separate the histogram for the creation of the plotting, so you can fill your histogram in parallel, and it will require less resources, and then you take the histogram and you just plot it. And it's also variable with respect to the number of variables, because we provide something that's called the variable registry, which is really useful to manage a lot of different variable plotting information. The last feature is to be user-friendly. We have a gallery of examples that really looks like matplotlib, with examples that you can click and get all the code. We have a comprehensive and easy to navigate documentation, and also we are available with only this command, and you can install them us with. Okay, so for the first feature is the style. So the style is already compatible with PRL and PRD with little to no effort. So for example, here I show two plots, which are from a recent Bell 2 paper published in PRD. And the two plots here are done with only one Plothist function, and you don't have to tweak anything. This is the output of the function. So it's really convenient to use. And in the end, you get publication-ready plots. Like here, comparison with a complex model and data. And yeah. So it's only one function to do that. So for the documentation, everything I will present in this presentation is in the documentation. So on the left, you can see the menu. First, you have like step-by-step guide, like as a tutorial to learn how to use the package. And at the end, you have an example gallery, as I said, where you can see all the example and click on them to get the code. And also you have the package reference where every function is described in detail. Okay, so let's start with the basic functionalities. So basic functionalities is to plot a 1D histogram and compare them. So here I list a bunch of functions that do that. We have the first one is utility functions, which is called makeHist. It takes 1D arrays and then it creates for you a boost histogram. So then you can use this boost histogram object to plot your histogram with all the functions that we provide. So if we could look at the plot on the left, bottom left, we can see like we can plot simple 1D histograms with Plothist. We can plot histogram with error bars from a Poisson distribution here. This is usually for data. We can also compare two histograms between each other with only one function here, and you directly get the comparison and the label and everything. If you only want the comparison plot, the comparison axe, you have the plot comparison, which only do that and plot on the comparison. And also all the functions here support functions, so you can also plot functions with this. Okay, so let's look at a simple example. So comparison between two histograms. So if we look at the code, it's really easy. We first make two histograms with makeHist, the utility function to get a boost histogram. And then just with this plot to hist comparison, you input the two histograms, you input the minimal number of variables, and then you get this plot with everything already aligned, everything correctly spaced. The pool here, we compare with the pool comparison. So the label is already, we know exactly what we're plotting on the comparison, which is really nice. And the comparison method, we have 6 available. We have ratio, pool, difference, relative difference, asymmetry, and efficiency. And you just have to change this. And the figure updates automatically. For the 2D plots, it's also the same philosophy. First, you make your 2D histogram with you make your boost histogram with this utility function, and then you plot. So on the left here, it's a simple 2D histogram plotting, and on the right, it's 2D with the X and Y projections. So this is a bit more complex, but it's still really easy to use. Now let's go to high energy physics example that maybe are a bit more relevant for HEP. So usually for HEP, you want to plot data and you want to plot a model, which is usually your background, that is stacked histograms, and then you want to compare them. So for this, we have 2 functions. We have the first one, the plot model, on the described on the left here, which plots any number of stacked and or unstacked histogram. And you can also input functions and it will do the plot of the model. So for example, here it's 3 stacked histogram, 1 unstacked histogram, and then it plots automatically the model, which is the sum of the 4, and it adds the statistical uncertainty on each bin. If you want then to compare with a data histogram, you have the second function, plot data model comparison, which takes the same stacked and or unstacked histograms or functions. So for example, here on the right, it's 2 stacked function, 1 unstacked function, which makes the model here, that is the sum of the 3. And you can compare it with data here, and here we chose the pool comparison. And this is to do this plot, it's only 1 function. So we can look at this function more in detail. So here, to make this big plot with a comparison of 3 stacked histogram and 1 data histogram, it's only 1 function here, which takes also a minimal amount of argument, which is like the data histogram and the stacked parameters, and the comparison, which one you want to use. And this is the result, the output of the function. So as before, everything aligned, the good label for the comparison. And yeah, and here also we added the luminosity here, because when you want to plot data, usually you want to add luminosity, and we have a utility function for that. As before, the comparison can be changed, and you can use any of these definitions for the comparison, and it's only by changing this argument, and everything will update. The last feature is that I want to show is the variable registry. So basically, it's to manage a lot of variable and to store the plotting information into one file, which is a YAML file. So it's really easy to read and to modify by hand. And so each variable will be identified by keys, and then we have function to create the whole registry. So create a registry with default values for each plotting information. We have a function to get the information, which will get a dictionary with all this information. And also we have a function to update information. Like here, for example, we update the range. And Cyril will show a more complex example with this registry. So everything I presented and more are available in the documentation. So here, for example, in the documentation, we also have an example to compare 2 functions and 2 data histogram together with this asymmetric comparison. Here we have also, we are able to compare 2 sets of histogram with different axes, like 2 axes, 1 for each comparison. In the documentation, we also have a tutorial to transfer roofit, zfit, or PyHF into Plothist. So here, for example, it's a roofit plot that has been transferred to Plothist, and then you have access to matplotlib, so it's much easier to modify. And also we have a bunch of utility functions to make it easier for the user to tweak the plot and to not spend that much time to tweak it, actually. Okay, so I'm already in my conclusion. So every example I've shown are in those 2 links, the documentation already. And Plothist is already used by a bunch of collaborators from multiple experiments. And the main feedback we get is that it's really a time saver, so they can spend more time doing physics than tuning the plots. And we are starting to discuss coordinating Plothist with the scikit-type package. So yes, so that's it for my side. And now we'll do the hands-on with Cyril. So you can click on this binder, but also the binder on the GitHub or the present. Yeah. Oh, Cyril?
Yes, to share, I just need you to unshare.
Ah, yes.
Thank you. Yes. Can you see my screen?
Yes.
Perfect. Thank you. Yes. Thank you. Hello, everyone. I'm Cyril. Thank you for having us today. So yes, as Tristan said, I will go through a couple of examples. So everything that that I will show you are also in the documentation of Plothist. So we have this plot gallery, and if you click on any of these plots, you have the full code that is needed to produce them. So if you click on the binder, I think maybe Tristan, you could share in the chat the binder link. You should get this instance. And yeah, so I will just go through a couple of examples, and just starting with yeah, the most basic example that is a 1D histogram. So we import a couple of functions. Then actually in Plothist, the default font is Latin modern fonts that are the same as in LaTeX. And we also wrote a script to install them automatically. So you may have to run this at the beginning just to install the fonts, and you will have to restart the kernel so that it works. Then for the examples, yeah, we are downloading some dummy data, and this will be the same dummy data for all the examples. So we have just a data set with 3 variables, so 3 columns, and a 4th column that is just a category column to split the data set in different categories. And the most basic thing you can do in Plothist is to create a figure, then make a histogram. So this function is, yeah, as Tristan said, just a helper to create a boost histogram. But you can also create a boost histogram without this function, and then input it in Plothist here. And Plothist actually is a very very light wrapper around the matplotlib axe hist. So actually, you can use all the arguments that are also available in matplotlib to tune your histogram. Moving to a more interesting example. So let's try to compare data with a functional model. So same as before, importing some data. You don't need to reinstall the fonts, just once is enough. The dummy data. So here I will make data hist. So I will say that my data is the category 8. So I'm just creating a data mask 8, and then make this histogram, getting the data. And yeah, this make hist function has the same interface as NumPy hist. Actually, that's why we created it, so that people coming from NumPy can create boost histograms with a very simple interface. But again, you don't have to use it. Here defining 3 functions, so 1 function for the signal and 2 functions for the background categories defined here. And then the plotting itself is only this cell. So we use the function plot data model comparison. We have the data hist as input. We have a model made of 2 stack components, 2 functions here, and 1 unstacked component, the signal. And plotting here, you see actually the result. And yeah, so it's not more complex than that. And it's quite flexible because we return also the axis. So you can, if you are not satisfied with the result, you can also change later the axis. And to change the comparison here, for example, to go from comparison to ratio, you just change this argument, and you have already the new comparison. And also, yeah, you have the flexibility in the model. Let's say that now you want to. So here the model is the sum of 2 stacked and 1 unstacked. But if you want to have everything stacked, you can just change here and move the signal to the stack list. just also put the label here. And okay, let's say we remove the color. And now, okay, very simple. Now you have 3 stacked function components, and you compare them with the data. Next example, also very similar to that one, but this time comparing data with model made of histograms. So this time we will use a couple more categories. So we have one for the data as before, but we will also define 3 background categories. So 3 masks. So saying that we have background 0, 1, and 2. And the important lines here are these 2 here, where we create the histograms still using the make hist. So one for the data histogram, still the same NumPy histogram interface. And the background hist, that is a list of 3 histograms, one for each background category. And the last thing actually is optional here. Yeah, boost histogram, actually, this is not Plothist. This is really a boost histogram feature. It's extremely flexible, so you can multiply the histograms by a factor, and it will scale automatically the histogram, and also the variance in each bin will be correctly scaled. So here we use that to scale the background to the data, and yeah, update the background histograms. And at the end, actually, that's exactly the same function as before, plot data model comparison, but this time we input histograms instead of functions. And we will also add luminosity on the accent. Yeah, that's one example of having to update the plot after it's created, thanks to the fact that we turn the axis. So if I run, oh sorry, I forgot to run this for the make of the histograms. And yes, you obtain this figure. So yeah, so out of the box, actually, you have already a plot with yeah, the model, all the components, also the comparison, the propagation of the uncertainties, and you can yeah, you can add the luminosity afterwards. One thing that I wanted to show again. So yes, if we change the comparison and I go to pool. Yeah, I wanted, so yeah, so you have it's immediately updated to the pool. And one thing that I wanted also to show is we have an argument that is model uncertainty. And so it's a Boolean, and if you put it to false, you can turn off the uncertainty, so of the model, sorry. So if you compare to before, with the uncertainties, we have the model statistical uncertainties, that is the sum of the components, and the explicit definition of the pools we are using here. And if you turn off the model uncertainty, this will disappear. And yeah, the definition of since we don't have a model uncertainty, it's also updated here. And the final example that I wanted to show you is an example of plotting 2D histograms, and also an example of use of the variable registry that Tristan was talking about. So yeah, similar to before, importing functions, importing loading this dummy data, and here in this cell, so we will here make use of the 3 variables that we have in our dataset. And we will create a variable registry based on these 3 keys. So I run this cell. And after this is run, this creates a YAML file here that I can open to show you. So we have the 3 variables, and each we have some default fields that contain plotting information for each variable. So a name, bins, range, min, max at the beginning, and yeah. So this is extremely flexible. You can add any plotting information that you may want to use in the future, and we have also functions to interact with this registry. So the first thing that we do here, we will update the ranges. So based on these datasets, the df, and for all the keys we have, we just want the min and the max to be updated in the registry. So if I run this cell, and I open again the variable registry, you see now that the ranges are correctly updated. And yeah, so you can also modify them manually, because if you want, if you have to redo many times the same plots, let's say that you are training a machine learning model and you have 100 variables and you want them to be plotted again and again, and same range, same number of pins. It's very useful to have all this information stored in an external file. So this said, I will just skip for now. And so the goal of this code is just to plot the correlation between each pair of variables. So here we just get the list of possible pairs between these three variables, and here we will loop and create a figure for each correlation. So the first thing that we do is we get the plotting information from the registry. So from the keys that are there. And then, yes, that's the equivalent of make hist, but in 2D. So make 2D hist with the bins and the range. And then the plotting itself is just this line, make 2D hist, where we input this 2D histogram. And if I run this cell, you'll see that, yes, now we have the three correlation shown among the variables. And the last thing that I wanted to show is, okay, let's say that now you want also to add units for each variable. So the easiest way is to update the variable registry. So you can either add a field by yourself and add a unit field, but we also provided a function here to update the variable registry. So for each variable, we will give a dictionary and ask to add a unit field in the registry. So if I run this and open again the variable registry, you see now that for each variable, we have also now a field unit. And to take this into account here, we would just need to change the code and also print the unit for each unit, and this is variable 0. If I paste this for variable 1, yes. So now, so you will have the unit. So the reason why we worked with this variable registry is that we found that it's quite often we had a new parameter we wanted to plotting information we wanted to add, and the most straightforward way we found was to use this variable registry. So for example, one field that is there by default, but you don't have to use it, but it's, for example, the legend location. If you have 100 variables you want to plot, sometimes it's also useful to say, okay, I want for this variable, I know that the legend should go there. So it's very flexible, and you really don't have to use it. You can use Plothist without at all the variable registry. This is just a helper if you want to have it, but you could also work with your own registry if you want. Okay, so that's what I wanted to show, and I think time now allows for question if you have. Thank you very much.
Thank you very much, and thank you. It's perfect timing. So you have plenty of time for discussions, and I will expect quite a few questions for sure. So let's see who wants to start. Yeah, Lawrence.
Hi. Thanks for the nice talk. I just have one maybe simple question. But so for the plot data model comparison, the documentation says the uncertainties are computed using kind of Poisson confidence intervals. Is there an option to provide kind of custom uncertainties to that as well and plot these?
Yes. So for that, indeed, so when we compare, so maybe I can show so that everyone is on the same page here. So actually, by default, the plot data model comparison is using a Poisson interval estimation. So actually, you can see that the uncertainties are not symmetrical. So for now, what we support are asymmetrical or symmetrical, where we just use the square root of the number of entries. We could consider also, yeah, custom uncertainties, but for now we just support these two.
Okay, thanks.
Good. Yep. Jim?
Yeah, so I guess I have two questions. One is at the beginning of the demo, you showed having to install LaTeX fonts. Is that really necessary?
No. It's it's not necessary at all to run the package. Actually, if you don't have them, it will just print a warning saying, "Oh, you should consider the LaTeX fonts." But no, all the notebooks and Plothist is working without that. It's not mandatory at all.
Okay, even a warning would be can be somewhat unfriendly, because if Plothist is used by another package, the user might not even know Plothist is involved, and the warning would be hard to understand.
This is true. Yes. Yeah. Since for now this project is kind of standalone, we didn't have to. We didn't have to think about integration into other project. But yeah, it's a good point. And as Tristan mentioned, actually we were contacted by Jonas from ZFit, maybe to start also discussing how we could coordinate with MPL and other packages. And yeah, this will be exactly that kind of questions would be important to consider. Yes.
This is also related to the fonts. Many of the LHC experiments have mandatory fonts. You have to use such and such a font, and so it could be different from the LaTeX one. This
is true. Yes, that's actually one. Yes, MPL Help actually is providing styles for the different collaborations. So for now we have just one default one, but we have already the interface to add other styles. But for now, there is only one, the default one. But indeed, yes, if collaborations are imposing fonts or figure sites, this we would also need to support.
Okay.
Yep, I'm not seeing any more hands, but yeah, but actually picking up on that one, once you start doing these things, there are always developments that can come up. You mentioned several connections. There are several obvious connections with scikit-help packages. You just mentioned you mentioned boost-histogram in your talk, for example. You just mentioned MPL Help. How are you discussing with the people there specifically how to glue or interlink or leverage? There's quite a few things that could be done there, actually, I think.
Yes. So actually, we are really at the start of the discussion. Actually, we will have a meeting on Wednesday morning with Jonas, and so here, so actually the two packages in the scikit-help that are kind of linked to what we do is MPL Help and Hist. So Hist in particular, so it also has plotting methods, including one-to-one Hist comparisons. One thing that is hard to do in Hist is to have the models with any number of stacked and unstacked components, because if the plotting method is a method of the class, it's hard to say, okay, which histogram would be the starting one, maybe the data one. So yeah, that would. So I'm not exactly sure how we could do that, but we could maybe be one way to plot Hist objects. And for MPL Help, the goal actually is also very similar. So MPL Help supports also other input possible inputs. On the other hand, in Plothist we have we provide also higher level functions, and as already mentioned, in MPL Help we have multiple collaboration styles while we have only one. So one way maybe would be one idea would be maybe to merge in a way, or to split and specialize in different things.
Yeah. Indeed. That's just thinking out loud as well. I think there's certainly room for a lot of discussion and collaboration. That's quite cool. In any case, it's very nice package. Really cool stuff the folks have done. I understand this was more focused as often within an experiment, and then you try to widen, which is still the way to go. Okay. Don't know if there's any more questions. So we still have time. I'm sure we'll come back to you folks, but this sounds like a perfect topic that would be taken up at the PyHap.dev workshop in person among developers. So we will re-advertise this, of course, during the week, but on Slack and so on. But have that in mind. That would be great, I think.
Thank you.
So, Mohammed, yeah.
Yeah, so I was actually wondering whether you can use for like a certain sub plot, you can define the layouts with MPL HEP, like whatever, maybe like collaboration information or whatever, and then like actually fill the plots with his plot. Is this like something that you can do?
Yes, so let me know. Let me know if I'm answering your question. But one thing, yes, one thing for us that was important is what it was really to be flexible. We don't want to impose that plot and end of the story. So by returning the axes, we allow actually then you can use any matplotlib function to tune again. So for maybe another for a specific collaboration, we may apply another function on this axis, maybe to change the size of the labels. But there is a flexibility to change each subplot thanks to the fact that we return this, and we could customize according to the collaboration.
Right, because I think you said like this is just like a wrapper around matplotlib, just I think as well as MPL help. I think.
Yes, it's also matplotlib. At the end, everything is matplotlib. Yes.
Yeah. Okay. Perfect. Thanks.
I guess this is a typical comment we could make in these situations. For such packages, there is a compromise between making it really trivial, as you would like to do certain things that are done all the time by lots of people, and then being able at the same time to try to customize when there is a need for something special. But for 90% of the work, you would like to have something that is essentially a call of a function, as we have been doing this here. And for in many packages, exactly the same route, which I think in the end is very practical, certainly very pragmatic. Okay, so we're perfect on time. Yeah, thanks everyone. So Sunil and Tristan again for this very interesting talk, and then we proceed to the next one.
Thank you.